In this lesson, we're looking at part 2 of chapter 5. So we're still working with discrete probability distributions, but now our focus is on finding the mean, variance, standard deviation, and expectation for a discrete random variable. Now, whenever you look in your textbook, you'll see these two formulas. One is to calculate the mean, and notice that mean is a mu, which means a population mean. So all the means for a probability distribution will be mu, and the variance, because it's a population, is sigma squared. So the standard deviation is going to be sigma. Now we can use the formulas, but just because of time constraints for our class, we're going to use the calculator for this. So let me show you how we're going to do that. So suppose two coins are tossed repeatedly and the number of heads that occurred is recorded. What will be the mean or expected value of the number of heads? Well, first of all, we need to know what the probability distribution is, and we're focusing on number of heads. So the number of heads in this distribution could be 0 heads, that tails-tail outcome, or it could be 1 head, or it could be 2 heads. So our probability distribution looks something like this. For 0 heads, there was just 1 outcome out of the 4. For 2 heads, there's 1 outcome out of the 4. And for 1 head, there's 2 out of 4. So what we're going to do to find the mean and the standard deviation and variance is to just plug this information into our calculator. And to do that, we're going to let our x1, our list 1 rather, be here. The x values is our list 1 and our probability of x is our list 2. So in our calculator we go to stat, edit, and back over here to list 1. We're going to type in 0, 1, and 2. And then for list 2, we're going to use 1/4. Notice I'm just typing it in as a fraction, 1 divided by 4. And enter. And then 2/4. And 1/4 again. Now in all probability distributions, that list 2, the probability should always add up to be 1. And each individual probability has got to be a number between 0 and 1. You know, probabilities can't be negative and they can't be greater than 1. So now we're going to calculate the mean, variance, and standard deviation. So to do that, we go to stat, arrow over to calculate, 1 stat, and we've got to use both list 1 and list 2. So make sure you, in the list, you've got list 1, frequencies list 2. If you don't see this on your screen of your calculator, make sure you type in list 1, comma, list 2, just like we did with the frequency distributions. And we're going to enter. So the mean for that distribution should be 1. Now notice we don't get the variance, but we do have the standard deviation. That's right here. So the standard deviation is 0.707. So what do we do to find the variance? Well, we just take that standard deviation and raise it to the 2nd power, just like we did with the frequency distributions when we were working on those. Now, when you're computing these values, mean, variance, standard deviation, the rounding rule is to round your final answer to 1 more decimal place than the place values for the random variable x. So our x values in that one were whole numbers, so we could round our answers to 1 decimal place. Okay. Here's another example. We're looking at rolling a die. So in rolling this die in our calculator, we're going to go to stat, edit, and in list 1, I need to clear out my list 1 and list 2. So in in list 1, I'm going to put in the numbers 1 through 6. And then in list 2, we're going to type in those fractions. Now you can do each one of them individually, but since they all have a denominator of 6, I'm going to take a little shortcut here. I'm going to type in just the numerators, which are 1. Type in 6 of those. Now you don't have to do it this way, but this is just a little shortcut. You could type in each one of them, 1 divided by 6, 1 divided by 6, 1 divided by 6. But instead, I'm going to take that whole list. So I've got in the ones for the numerators. So I'm going to go back up here to the title of the list and say, okay, let's take everything in list 2 and divide it by 6. So the way I do that is I say, take second 2, everything in list 2, and divide it by 6. Look at my command line now. List 2 divided by 6. So when I hit enter, it does that with all of those ones. It takes each one of them and divides it by 6. Saves me a little bit of typing. But now I want to calculate to find the mean. So I'm going to go back to stat, calculate 1 var stat. Make sure you're using list 1, list 2. So if you don't have this command, be sure to type in L1, L2, and then calculate. So our mean for this distribution, this discrete probability distribution, is 3.5. And our standard deviation, if we round it off to the nearest tenth, should be 1.7. Now to find the variance, we take this number, this 1.707825128, and raise it to the second power. And that's going to give us the variance. Now, they've done this problem by hand using the formula. Notice they got the same mean. The mean they have is 3.5, and our mean over here is also 3.5 on the calculator. In this one, what we're asked to do is calculate the mean, and this probability distribution is not a classical one, but this one is an empirical. So what we're going to do is go back and in stat, edit, we're going to type in our values of the random variable in list 1. So that's the 0, 1, 2, 3, 4. And then in list 2, we're going to type in the corresponding probabilities for those. Clear out list 2. And we put in 0.06. 70. 0.03. And instead of using the formula, we're using our calculator, and then just stat calculate one variable stat on list 1, list 2. Same process. So this should feel very familiar to you since we've done this type of thing before. And as you notice here, the mean ends up being 1.23. They've rounded off to 1 decimal place in our answer over here. And our standard deviation is 0.64583, blah, blah, blah. Okay, so we would round that off also to 1 decimal place. Our standard deviation would be 0.6. Back on this problem here with the variance and standard deviation in example 5-5, we can go back and enter our information in list 1, list 2, calculate 1 variable stat on the 2 list, and this would be our standard deviation, but then we go back and square that answer, square the whole thing that you see in the calculator to get the variance. Here's another example that we can do. So let me clear my list. So this time we've got a talk radio station that has 4 telephone lines. And if the host is unable to talk, in other words, there's a commercial or he's talking to a person or then the other callers are placed on hold. When all the lines are in use, others who are trying to call in will get a busy signal. So the probability that 0, 1, 2, 3, or 4 people will get through is shown in this distribution. Find the variance in the standard deviation. So here again, this is just like before. So in list 1, we're going to put in our values for x. And then in list 2, we're going to use our probabilities. 18. And then we're going to go back and calculate one variable stat on those 2 lists. List 1, comma, list 2. If you don't see the screen, make sure you tell list 1, comma, list 2. And then enter. And this time we're looking for the variance in the standard deviation. Now what we're going to be receiving is the standard deviation, this 1.1. To find that variance that they have on the slide there of 1.2, we'd have to take 1.123343224 and square it. And when you square that, you're going to get 1.2 rounded to the nearest tenth. Now the question here is, if the host is unable to talk and the people put on hold, when all the lines are in use, others who are trying to call in will get a busy signal. Should the station have considered getting more phone lines? Well, as we look at this problem here, notice that here on the calculator, the mean is about 1.6, and the standard deviation is 1.1. So let's go back and think about Chebyshev's theorem. Chebyshev's theorem talks about how that at least 75% of the callers will get through if we're looking at 2 standard deviations from the mean. So if we take that 1.6 and we add 2 standard deviations of 1.1 and another 1.1, then that's going to give us 3.8. So we know that at least 75% of all the callers would be able to get through. So the station manager makes this decision. No, the 4 phone lines are going to be sufficient. And this is his rationale why he makes that decision. Because at least 75% of the data occurs within 2 standard deviations of the mean. Expectation or expected value is just another name for the mean. Notice that the notation looks a little different. Is E of X for expected value, but that's the same thing as mu, the mean. So if we've got a distribution and we're trying to find the mean, then we can just go back and put it in our 2 lists, just like we've done before. Well, it doesn't look like I'm going to have enough time to explain this problem on this video, but I will make a separate little video for this so that you can see the explanation of how this works. Thank you.